Hey, what's up? It's Powell, and in this video I'm going to show you how to graph a cosine function using the box method. I've done a previous video on the box method of graphing sinusoids, so if you haven't watched that, I will make reference to it, but you might want to watch that before you watch this one. You can click the annotation below to do that. The function we'll be working with this time is g of x equals 1/2 cosine of 1/4 x minus pi plus 2. Now, as before, the first thing we have to do is make sure to factor out the coefficient of x inside the parentheses. And when we do that, we get g of x equals 1/2 cosine of 1/4 parentheses x minus 4 pi, double parentheses to close the cosine, plus 2. And now we can identify the values that will affect all four of our transformations. The first one is vertical shift, and that of course is the value on the end. Let's make it red instead. And because the value is plus 2, that means the midline of the function is going to move up 2. So midline up 2 units. The next one is amplitude, and that's the value right up front. Usually right up front, not always, but usually. And we have 1/2, which means that the max and min values are max and min 1/2 units from midline. So we're going to have a very small graph, small vertically. The next is the phase shift or horizontal shift. That is the value added with x inside the parentheses, and since we have a minus 4 pi, that means that the starting point for our graph is going to be 4 pi to the right. So starts at 4 pi. Now again, because it's a periodic function, there's really no starting or finishing point. It's going to repeat infinitely in each direction. But for the purposes of the box method, it'll start at 4 pi. And then finally, the value that affects the period is 1/4. And that means our period is 2 pi divided by 1/4, or 2 pi times 4, or 8. Whoa, that's not an 8. 8 pi. So this is going to be a very small graph vertically, but it's going to be a very long graph horizontally. And because of the bigger values for period, we're going to scale both the x-axis and the g of x-axis. So my graph is going to look a little different than the last one. Usually I like to go by pi over 6s, but in this case we're going to go by different units. That should be long enough. I guess we'll find out. And we have x, and we have g of x. Now, as I said, every space on the x-axis will be scaled differently, and in this case, since our starting point is at 4 pi and our graph lasts 8 pi, we're going to make each space 1 pi. And then for the g of x axis, we'll make every 2 spaces 1, which means that every space is a half. And that will facilitate our midline and max and mins. So first order of business, we're going to go in the order that it's written, so vertical shift first. So the vertical shift is up 2 units. So the center of the graph is going to be at +2. The max and mins are a half a unit above and below the midline, and since we're going by halves, it's going to be 1 full space above and below. Scupper's still watching from over there. Then our starting point is at 4 pi. And again, since every space is 1 pi, 1, 2, 3, 4, it's 4 spaces to the right. And the period, as with before, it lasts 8 pi, which doesn't necessarily mean that it stops at 8 pi on the x-axis. It just lasts for 8 pi units. And since every space is pi, it's going to last for 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces from the starting point. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And now that we have our box, we're talking about this box right here. Our graph, one period of our graph will fit inside of there. So, before we graph it, let's talk about how cosine behaves. In the previous video, we found out, or we talked about how sine behaves like this. It starts at the midline. A quarter of the way through, it goes to its maximum value. Halfway through, it goes to its midline again. 3/4 of the way through, it's at its minimum, and then it ends where it begins at the midline. Cosine is very similar. Cosine is just a little phase shift away from being sine, but in the purposes of this method, it does behave a little differently. It starts at its maximum value. 1/4 of the way through, it's at its midline. Halfway through, it's at its minimum. 3/4 of the way through, it's at the midline again, and it ends at the maximum. So notice that if I take sine and shift it over just a little bit, they all line up. That's no coincidence. But obviously, for the purposes of this function, we're going to follow that pattern. So now, let's go over to our graph. We start at the maximum. 1/4 of the way through, we're at our midline. Halfway through, we're at our minimum. 3/4 of the way through, we're at our midline again. Then we end at the maximum. You get a good graph that looks something like that. And if you want 2 periods worth, I'm not going to go any more in the right direction, but let's do a period's worth of cosine in the left direction. So again, I count out 8 spaces, because again, it lasts 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Nearly perfect there. And then again, if I start at this part, start at the leftmost corner, top leftmost corner in this case, 1/4 of the way through at midline, minimum, midline, maximum. You get another period's worth of cosine. You can just keep repeating this in every direction using that same exact progression. And that's graphing cosine. If you like this video, please subscribe and comment below on any topics you'd like me to cover in the future. And stay tuned for more graphing sinusoidal functions and trigonometric functions, as well as all other algebra, geometry, and trig topics. Thanks for watching.